Hello and welcome. This is the first class for HS first year mathematics. We are going to start our syllabus from chapter 1. Chapter 1 of your syllabus deals with sets. So let us start the chapter. What is a set first of all? Well, set is a collection of distinct and well-defined objects. So let me first define it. A set is a collection. Set is a collection. Collection of what? It is a collection of well-defined, definite and distinct objects. Okay. So from the definition we find that a set is nothing but a collection. It is simply a collection of something, of some objects. It is simply a collection. So every set is nothing but a collection. Collection of what? Collection of well-defined, definite and distinct objects. So it contains every set is nothing but a collection of some objects which are well-defined, which are distinct, which are definite. For example, if I say the set of all districts of Assam, set of all districts of Assam. So is this a set or not? Yes. If we say all districts of Assam, so it includes Hailakandi, Silchar, Karimganj, Badarpur and all the rest of the districts. So the number of districts in Assam, in the state of Assam, the number of districts is fixed, and we know all the districts, and each district is different from the other. So we see that the number of districts or the districts are well defined, they are definite and they are also distinct. That means Karimganj is not the same as Silchar, and Silchar is not the same as Hailakandi, or Badarpur is not the same as this. Every district is different from the other district, and total number of districts is definite, we know, and the set and this is known as the set of all districts of Assam. So this is just one example. I can say another example. This is also a set. The set of all natural numbers. The set of all natural numbers. Is this a set or not? Yes. Why? Because we know all natural numbers 1, 2, 3, 4, 5, 6 and so on. So all the natural numbers are known and they are different from each other. See, 1 is not the same as 2, 2 is not the same as 3, 3 is not the same as 4 and so on. So these are well defined. These numbers are well defined, they are definite and they are distinct from each other. They are distinct from each other. You cannot say 1 is 2 or 2 is 3. So if you say this is a collection, then this becomes a set of natural numbers. So this is how a set is defined. So notice that I have included a bracket here. So in every set, this is the common custom that you should enclose this set with this type of bracket. Every set is enclosed with this type of bracket, and what follows inside it are the contents of the set. So this is the set of, what is this? This entire thing is a set of all natural numbers. So this notation indicates that it is a set, and inside it we have the contents of the set. These contents are known as elements. These contents are known as elements of this set. Okay. So now it must be clear to you that a set is nothing but a collection of certain well-defined, distinct and definite objects. Let me give you some more examples to make it even more clear. For example, the set of all districts in Barak Valley. Now take your second here and in your mind think about all the districts of Barak Valley. What comes in your mind? Obviously there are 4 districts. First one is your own district, Karimganj. then we have Silchar, then we have, yes, Badarpur, and finally we have Elagandi. So here are 4 districts. So if we are going to write the set, so this is the set of all districts now. So in set notation we must first of all include this type of bracket, then we should write the elements inside the set. First element is this, comma, second element is this, comma, third element is this, and finally the fourth element is this one, bracket close. So this bracket and whatever contains inside the bracket, this entire thing, this whole thing is nothing but this set of all districts in Barak Valley. So the entire chapter deals with these type of things. These are known as sets. They are nothing but collection of well-defined, definite and distinct objects. These are all well-defined. They are distinct because they are different from each other. See, there are not 2 Karimganges present, not 2 Silchar, not more than 1 Badarpur. So each and every element is different from each other and they are definite, well-defined. So now it must be clear to you what is a set. Now let us see some examples which cannot be judged as set. We cannot say that this is a set. For example, let me say set of all beautiful places, beautiful cities in Assam. Now can you say that this is a set? Obviously not, because how can you judge which city is beautiful? Which city is beautiful? How will you judge it? Suppose you like this city Silchar, but someone else may not like Silchar, he might like Karimganj more. So you cannot say this city is more beautiful than this, or this city is beautiful and this city is ugly. There is no criteria to judge certain things. So this thing is first of all not well defined. That's why we cannot say that this can be a set. So this is an example in which we can say that this does not classify as a set. So this is not a set. We cannot say this is a set because this is not well defined. Why it is not well defined? Because there is no criteria to judge a city whether it is beautiful or ugly. Another example, let me say set of all delicious food items. Now this again is another example in which you cannot say that it is a set. Why? Because again the deliciousness, how can you say which food is delicious and which food is not delicious? Maybe the food that you find delicious, it may or may not be delicious for the other person. So there is no criteria to judge a food whether it is delicious or not. So you cannot say that this is a set. Obviously this is not a set, because again for the same reason it is not well defined. Another example, set of all happy days in a year. Again this is another example. You cannot say which day is happy in a year and which day is sorrowful and which or not happy. So this is again another example which is not a set. So we see that a set is always nothing but a collection of well defined. It has to be well defined. You have to define it mathematically, or it has to be logically correct. Well defined, definite and distinct objects. This is known as set. And add one more line here, the contents of any set are known as elements of the set. If I explain this line, it means that, for example, let us have a set of 5 numbers, 1 2 3 4 5. This is a set, for example, every set, remember every set is represented using this type of brackets, and whatever is inside them you have to separate by commas. See 1, 2, 3, 4, 5. So and each and every entry here is known as a element of this set. So this set has how many elements? 1 is the first element, 2 is the second element, 3 is the third element, 4 is the fourth element, 5 is the fifth element here. So this entire set has a total of 5 elements inside it. Each and every entry is known as an element of this set. Remember this. Okay. Now in most of the books a set is represented using a capital letter A. In your examples you will find that suppose A is equal to 1, 2, suppose B is equal to 5, 6, 7, in this fashion. So a set is represented using the capital letter of English alphabet. Okay, and a set is always represented using this type of bracket. Now let us study how is a set represented. So let me rub it out. You must now understood, you must have understood probably that what is a set. Now let us represent sets. Representation of sets. Let us see how a set can be represented. Up till now we have known that a set is represented using this type of bracket, and whatever element that was present inside the set we have to separate by commas like this. Okay, this type of representation, actually set can be represented in two ways. There are two ways in which a set can be represented. This way of representation of a set is known as the tabular method. It is known as the tabular method. Oh, there is another name for it. We call it the roster method. R-O-S-T-E-R, roster method. So this is the name of the method. This is the roster method of representation of any set. What is the roster method? Square this brackets, third bracket, then all the elements are represented using commas. All the elements are separated using commas. All the elements you have to list one by one inside the bracket, and you have to separate them using commas. This type of representation is known as the tabular method, or sometimes we call it the roster method. Okay, I am out of ink, so let me refuel it. Give me a second here. Okay, the second method, so this is the first method, we call it the tabular method or the roster method of set representation. There is a second method, we call it the set builder method. The set builder method. So any set, if you have one set, you can choose in which method you want to express the set. You can either choose to express this in this tabular method or roster method, or you can choose to express the same set in the set builder method. Now what happens in set builder method is that it recognizes a single property of all the elements. Look at this set. Take a good look at this set. What is the common thing that you find in each and every element of the set? What is the common property? 1, 2, 3, 4, 5, 6. What is the property? Common property. Yes, the common property is that each and every element is nothing but a natural number. 1 is a natural number, 2 is a natural number, 3 is a natural number, 4, 5, 6, 7, 8, 9, 10. All the numbers are nothing but natural numbers. So the common property of all the elements is that each and every element is nothing but a natural number. So I can write the same set in set builder method as bracket. I will say that each and every element is nothing but x. this is x, this is x, this is x, is equal to x, such that this symbol is known as such that. The name of this straight line is known as such that. So this set is equals to x, means a collection of all x's, such that x is a natural number. X is a natural number. Technically this set and this set, they are the same. So if you have a set, if you have a set of natural numbers, you can choose to represent the set in this fashion, or you can choose to represent it in this fashion. They are both the same. Look, it is saying that it is a collection of several x's, such that there is a property. On which property you are selecting this axis? The property is that this x will be nothing but a natural number. So that means this x, in first place it becomes 1, in the second place again it is a natural number, so it becomes 2, in the third instance, since it is a natural number, it would become 3, next 4, then 5, then 6, the same thing. So let me give you another example of set builder method. Let us say you have a set like this, or let me rub it out first. Understand it properly. It's very important. You will definitely find a question in your final exam regarding the method of representation of sets. Let us say we have a set 1, 4, 9, 16, 25, ... like that. It goes on. It is never ending. So now how to represent this set in the set builder method? First of all, every time you remember this, while constructing the set builder method type of set, you always have to look at this set and find the common property of all the elements. What is the common property that each and every element contains here? Look, 1, 4, 9. Can you think of any common property? I'll give you 2 seconds to think about it. Yes, the common property is this 1 is nothing but 1 square. This 4 is nothing but 2 square. 9 is 3 square. 16 is 4 square. 25 is 5 squared, and so on. So we see that each and every element is nothing but the square of a natural number. 1 is the square of 1, 4 is the square of 2, 9 is the square of 3. So each and every element is nothing but the square of a natural number. So how can we write the same set in set builder method? We will say that it is a collection of x's. Each and every element we call it an x. Suppose we are calling this an x in the first place, then x becomes this number, then x becomes this number, after that x becomes this number, like that. So we are calling it a collection of x's such that x is the square of some number. It is a collection of x. It is a collection of several x's in such a way, or in such that x is nothing but the square of something. What is that thing? N. And what is n? N is, or we can use this symbol, n belongs to the set of natural numbers. I will explain to you what this symbol means. This symbol means belongs to. For the time being, you consider that n is a natural number, and I am giving you that this is a collection of all x's in such a way that x is nothing but the square of certain number n, and in the next comma we are using a comma here, and we are saying that n is nothing but a natural number. N is natural. N is the set of natural numbers, capital N. Remember, capital N means, in your entire book, the capital N means the set of all natural numbers, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I am saying that n belongs to the set of natural numbers. The symbol means n belongs to the set of natural numbers. So n, in the first time it will become 1, in the second place it will become 2, third place 3, fourth place 4. When in the first place it becomes 1, That means x is equals to n is equal to 1. So x is equal to 1 squared. 1 square 1. In the next instance, n becomes what? 2. So x equal to 2 squared. 2 square is 4. In the third instance, n is equals to 3, right? So when n is equal to 3, x equal to 3 squared, and it is a collection of x's, so 3 squared is 9. Similarly, when n is equal to 4, 4 squared is 16, it becomes 16. N is equal to 5, 5 square is 25, becomes 25, like this. So this is the set builder method form of representation. I will explain to you what this symbol means. This symbol is written in this fashion, like this, and it means belongs to. This symbol means belongs to. Now let me explain to you what does this belongs to mean. For example, let us say, for example, we have a set A is equals to 1, 2, 3, 4. I have said it previously, I have said it that each and every content, A is a set of 1, 2, 3, 4. So each and every content of this set is nothing but an element of the set. 1 is an element of this set, 2 is an element of this set, 3 is an element of this set, 4 is an element of this set, right? So we can say that 1, that is an element of the set, is belonging to A, or 1 is an element of the set A, right? You can also say that 1 is an element of the set A, or you can say 1 belongs to A. In a similar fashion, you can say 2 belongs to A, 3 belongs to A, 4 belongs to A. Can we say that 5 belongs to A? No, 5 does not belong to A. This is another symbol, does not belong to. 6 does not belong to A, and so on. So now it must be clear to you what does this belongs to symbol stands for. It stands for that some element is a part of some set. 1 is a part of this set, 2 is a part of this set, or 3 is an element of this set. 1 belongs to A, 2 belongs to A, 3 belongs to A, 4 belongs to A. So keep this in mind. Now in this example, I have shown you that n belongs to, small n belongs to capital N. Remember, capital N is a standard set. Everybody should know that capital N is a constant set. Everybody uses it, and n is always equal to 1, 2, 3, 4, 5, 6, 7, 8, and so on. It goes on for infinity. So capital N is a very well known set, and we use it to standardize the set. We use this capital N as a standard set. So n is equal to 1, 2, 3, 4. You have to keep this in mind. Now here x is equal to n squared, and n belongs to the set of natural numbers. So when n belongs to the set of natural numbers, that means n can be 1, because 1 belongs to n. 1 belongs to n, right? And I am saying that n belongs to n. So n is the variable. N can take value of 1, small n can take value of 2, small n can take value of 3, 4, 5, 6, and so on. So when n takes the value of 1, x equal to 1 squared, it is 1. When x takes the value of 2 from this, it becomes 4, because it is 2 square, right? So this is the way to express any set in the set builder method. You will definitely find a question in your final examination. Let us move on and give you another example so that you may be able to understand. Let us say we have a set. Now this is a very easy example. Let us say we have a set 2, 3, 5, 7. In set builder method, how will you express this set? Now remember that I have told it previously that while constructing the set builder method, you have to first of all notice for any sort of pattern in these elements. What is the pattern that you see in these elements? Can you see any sort of pattern? See 1, 2, 1, after that it becomes 2, then 3, 4 is not there, then 5, 6 is not there, then 7, 8, 9. So what are these numbers? These numbers are prime numbers, right? See, if you look at the number line 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. What are the prime numbers? 1 is not a prime number. You already know that. 2 is a prime number. 3 is a prime number. 4 is not a prime number. 5 is a prime number, 6 is not a prime number, 7 is a prime number, 8 is not a prime number, 9 is not a prime number, 10 is not a prime number, then 11 is a prime number. So we are seeing that 2, 3, 5, 7 and 11 are nothing but prime numbers. So we can see that this has 4 elements and it is a set of prime numbers less than 11. Can we say that? Can we say that it is a set of prime numbers less than 11? So less than 11 are 4 prime numbers, this and that. Okay. So what is the property that we recognize? Can you see any property? Yes, we see the property, and that is it is a collection or it is a set of prime numbers less than 11. So in set builder method you will say that this is a collection of several x's. We will say this is x, this is x. First of all, this is x. In first instance this is x. After this is defined, we shift the x here. After this is defined, we shift the x here. After this is defined, we shift the x here, like that. So this is a set of x's, collection of x's, such that x is a prime number. X is a prime number less than 11. If you say this is defined now. So it is a collection of x's such that x is a prime number less than 11. So the first prime number, what is the first prime number that is less than 11? It is 1. What is it is 2. What is the second prime number that is less than 11? That is 3. We get 3. What is the next prime number that is less than 11? It is 5. So it is 5. What is the next prime number? It is 7. It is 7. So this set and this set, they are both the same. Just the ways of expressing the same contents is different. Here we are expressing it using a simple property of the set. Here we are expressing the set in elementary form. That means we are representing each and every element separately using commas within a bracket. So now that we have understood the two types of representation of sets, one is tabular method, other one is set builder method. In examination you will definitely find a question here. Now let us try to solve some problems so that we may be able to understand which method to use when representing a set. So write a question. Express the following sets. Express the following sets in roster method. In roster method. Number 1, the set of roots. The set of roots of the equation x squared minus 3x plus 2 equal to 0. So this is a question and it is asking you to find the set of what? The roots of the equation. This, if you know from quadratic equation, you already know that the roots of this quadratic equation would be 1 and 2. If you solve using your quadratic equation formula from class 10, you will see that it has two roots, 1 and 2. So both these roots are distinct. Remember this definition of set. Set is a collection of well-defined, definite and distinct objects. So well-defined. How it is well-defined? Because these are the roots of this equation. So it is well-defined. It is definite. Yes, it is each and every element is a root of this equation. It is definite. And thirdly, it is distinct. 1 is not the same as 2. 2 is not the same as 1. So the set would be to use this symbol, and inside this bracket we will use these roots, and this is the set. The set of the roots of this equation is bracket 1 comma 2, and this method is the roster method of representation. Let's go to question number 2. The set of the letters of the word Mississippi. Mississippi is a very old city in the United States of America. So it is just a name of the city. Now you are required to find the set of what? The letters contained in this word. So how many letters does this word have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters. So there are 11 letters inside this word. But if you remember the definition of set is a collection of well-defined, definite and distinct objects, right? So these letters need to be in distinct form. The first letter is M, done. Second letter is I. Third letter is S. What is the fourth letter? Another S. But we have already mentioned S, so there is no need to write another S. Okay. Next letter is I. I have already mentioned. S we have already mentioned. S we have already mentioned it. I is already there. Then we have P. It is a new letter, P. Then we have another P. P we have already mentioned. I we have already mentioned. So there are 4 distinct letters. Each letter is different from the other. So this distinct collection of letters, this is well defined because these are letters from this word and these are distinct also. So we can say that this would be a set of the letters M, I, S, P. So that is the answer. Okay. Let's go to question number 3. The set of months with 31 days. This is another example. So try to find out how many months and which are the months that contain 31 days. The first would be obviously January. January has 31 days. Next February has 28 days. After February it's March. March has 31 days. Then April has 30 days. May has 31 days. June has 30 days. July has 31 days. August has 31 days. September has 30 days. October has 31 days. November has 30 days. December has 31 days. So how many are there? 1, 2, 3, 4, 5, 6, 7. Are they definite? Yes. Are they well defined? Yes. They are the months with 31 days. Are they distinct? Yes, all of them are distinct. January is not the same as March. Each and every name is different. Each and every month is different. So they are distinct. They are different from each other. And we are required to find a set of months with 31 days. So these are the months with 31 days. So what would be the set? The set would be this notation: January, March, May, July, August, October, and then lastly December. So this is the set of months with 31 days. Let's move to question number 4, and you try to do it. Very easy, same as this one. The set of the letters of the word coffee. Very simple. Try to do it. What are the letters? First of all, write the letters C, then we have O, then we have F, another F, no need to mention it again, already I mentioned it. Then we have E, another E, same thing. So there are 4 distinct letters. What are these? C, O, F, E. So in set notation, we will use this symbol. In roster method, we will use this bracket. Then start writing the letters. C is the first element. The next element is O. The next element is F. The next element is E. So this is the set. So it must be clear to you now how to represent sets using the roster method. Let's move on to next question. And in this question, we will try to represent sets using the set builder method. And it is very important. set builder method. Question number 1. Pay close attention here. A, B, C, D, dot, Y, Z. So if you remember correctly, what did I tell you? You have to first of all recognize any pattern that is present in these numbers. What is the pattern that you see in these numbers? The pattern is that each and every element in this set is nothing but the letter of an English alphabet, and each and every letter is capitalized. So see, this is a set of capital letters of the English alphabet. So the common property between all the elements is that each and every element is a letter, capital letter of English alphabet. So how to represent this in set builder method? You will say this is a collection of several x's in such a way that x is a capital letter, of English alphabet. This is the set. Very simple. Let's have another question, and this is very important. Try to pay close attention to this question. We have 2, then 4, 6, 8, 10, 12 and so on. Can you recognize any common property between these numbers? What is the common property? Take a minute to think about it. What is the common property in these numbers? Yes, the common property is that each and every element of this set is nothing but an even number. You can see 2 is even, 4 is even, 6 is even, 8, 10, 12 and so on. So all of the elements of this set are even numbers. So I will say that this is nothing but a collection of several x's such a way that x is an even number. X is an even number. Simple, done. Now there is another way in which we can write this in a much more beautiful fashion, in a much more mathematical fashion. Can we say that it is a collection of several x's such that x is equal to 2 times a variable n. Small n is a variable and x equals to 2 times the variable 2n, comma small n belongs to the set of natural numbers. Can we say that? Yes, because the set of natural numbers contain 1, 2, 3, 4, 5, 6 and so on. So n is a variable that belongs to the set of natural numbers. So n in first place becomes 1, in second place becomes 2, third place becomes 3. When in the first place it becomes 1, n is equal to 1, x equals to 2 into 1 is 2. In the second place n becomes 2, 2 into 2 becomes 4, x equals to 4, it is 4. Third place it is 3, so 2 into 3 is 6, 4, 2 into 4, 8, 2 into 5, 10, 2 into 6, 12 and so on, so on. So this is the more beautiful form of set builder method. You can either represent it in this manner or you can represent it in this manner. It is much more beautiful and this is also valid. Okay, let's move to question number 3. Another question, very interesting. 5, 10, 15, 20, 25 and so on. Remember, in set builder method you have to first recognize the common property between the elements. What is the common property? Each and every element is a multiple of 5. See, 5 ones are 5, 5 2s are 10, 5 3s are 15, 5 4s are 25, 5s are 25 and so on. So each and every element is nothing but a multiple of 5. So I can write it like this, that it is a collection of x's such that x is a multiple of 5. Multiple of 5. Or I can write it in mathematical fashion. It is a collection of x's such that x is equals to 5 times n, comma n belongs to the set of natural numbers. N becomes 1, so x becomes 5 into 1, 5. N becomes 2, x equals to 5 into 2, 10. N becomes 3, x equals to 5 into 3, 15. n becomes 4, 5 into 4 is 20, and so on, so on. So this is much more beautiful. Okay, here is question number 4, and I leave it to you. Try to think about the answer. Question number 4, I give you a set 10, 100, 1000, 10,000, ... Try to express it in set builder method. What is the common property in all the elements? What is the common property? Try to find out the common property. Yes, the first property is that 10 to the power 1 is 10. 10 to the power 2 is 100. 10 to the power 3, 1000. 10 to the power 4, 10,000, and so on. So these are nothing but powers of 10. These are nothing but powers of 10. So can I write it in this fashion? It is a collection of x's. It is a collection of several x's. Remember, why do we say collection of x's? Because when we say collection of x's, we are saying that in the first place x becomes this number. In the second place x becomes this number. In the third place x becomes this number. Fourth place x becomes this number, and so on. So x individually keeps on taking values this, then this, then this, then this, then this, and so on, so on. So I am saying that it is a collection of x's such that x is 10 to the power some number n or some variable n, and n belongs to the set of natural numbers. You see, natural number starts from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So n is the set of natural numbers. N is the variable that belongs to the set of natural numbers. So n will take value of 1. When n is equal to 1, 10 to the power 1 is 10. So x takes the value of 10. When n is equals to 2, when n takes the value of 2, x equals to 10 to the power 2 is 100. So x comes here and it becomes 100. Next, 10 to the power 3, x comes in the third place, it becomes 1000, and similarly 10,000, and so on and so on. So this is a beautiful example, and I hope you understood it properly. Let me give you another example. It is a simple one. It is a very simple one. 1, 3, 5, 7, 9, 11, so on. Don't waste time in this. It is a very easy question. What is the common property in all these elements? Yes, the common property is that each and every element is nothing but an odd number. So how will you write it? It is a collection of several x's. It is a collection of x, or it is equal to x, such that x is an odd number. X is an odd number. Simple. So up till now, so this concludes our first class for today. This is enough for today, and I'm sure you are successful in understanding what is a set and how many and what are the various ways in which we can represent a set. There are two ways of representing a set. The first way is roster method or tabular method, and the second method is the set builder method of representation of sets. And we have solved several examples, and we have also recognized that set is a well-defined collection of numbers or objects, and these objects must be well defined, they must be distinct, and they must be definite. And the contents of set are known as elements of the set, and we have recognized that this is a symbol to represent that 1 belongs to the set A. In a similar fashion, 2 belongs to set B. We can say this symbol stands for belongs to, and this symbol means that 1 is an element of the set A. For example, if you say that this is the set M, we are going to say that 3 belongs to set M. So we can say that we will write it as 3 belongs to set M. Right, so we have also understood the symbol epsilon is also read as belongs to, or it's a part of set. Okay, and we have solved several examples to show you how to represent sets in both tabular form or roster method and also in the set builder method. In our next class, we will discuss some more advanced topics in set theory. For till then, goodbye and thanks for listening.